Everybody, this video is for the lesson for Wednesday, February 14th. Happy Valentine's Day. It's a short one today because we have a shortened class period. So let's go ahead and get started. So we're going to begin with your chapter 1 notes. We're going to finish those up today. And you'll notice at the very end of your notes, I have these blank notes for you. So now's the time that you are going to start paying attention to keywords and questions. We're going to have a demonstration today in class. And so you are the one that's going to put down the keywords and questions, kinesthetic activities, things that we do on the left side, and then describe them, write your notes on the right side. Okay, start off by filling in the top right where it says your notes for. Go ahead and put phase change 1.5. And in the left, I'm going to have you guys put in key concept number 4. And then in the right side, you're going to go ahead and write it down. So we've been talking a lot about macro scale, molecular scale, and key concept number 4 just kind of puts it all together and says a phase change is when the molecules that make up a substance experience a change to their freedom of movement, to their FOM. And the result is a macro scale change in the appearance. Go ahead and pause the video and go ahead and write that down, please. And then we have key concept number 5. Key concept number 5 says a change that can be observed at the macro scale can be explained by a change at the molecular scale. It's just putting the two together and helping you understand that whatever phase matter something is in, you can explain that phase by what's happening at the molecular scale. Think back to our sim. Think back to those purple molecules that are moving around in different ways, and understand that because they're moving in that way, we see them as a solid, as a liquid, as a gas. Go ahead and write this down and then continue the video. All right, so now that you've got a better understanding of how the molecules move at each phase, I want you to go back to your student-generated models. This is on page 4 or 5, I think. I can't remember. You had already gone through and drawn a picture of molecules. I think we used circles to represent 6 molecules of water. And I asked you to describe what they looked like as a solid, as a liquid, as a gas. And so I just want you to go back and revise now that you understand it maybe a little better. Revise it if you need to. What you should be seeing, and I want to see your model when you come back. I want to check that. So show that to me. I'm going to take just a completion grade for this. What I'm looking for is I want to see that you understand that a solid holds its shape and does not take the shape of its container. Gravity is on, so your 6 solid molecules should be close together in some kind of a clump. They don't have to be in a cube, but they can be. But they should be resting on the bottom of that box because the box is the container. So think of an ice cube. Something like a shape of an ice cube, a solid piece of ice. Now, as a liquid, those 6 molecules would be a little bit farther away from each other, just a little bit, and they would take the shape of the container, and so you cannot have your molecules on top of each other. They would take the shape of this container of a box of liquid. I guess the only way you could have that is if you drew really big, fat, round molecules and you didn't have enough to put them all kind of laying flat. But they would take the shape of the container. They'd be a little bit farther apart than what the solid molecules are. Your solid molecules should be touching. If you have space in between your solid molecules, revise it, redraw it, put them close together. Remember, solid molecules vibrate together in place. They have very high molecular attraction and a very low freedom of movement. So they're stuck together. A liquid, they're going to be just a little bit farther apart, close enough that they still have molecular attraction, but now they're able to slide past each other. And then your 6 molecules of water is a gas. It's water vapor. These are going to be way far away from each other. It's going to be filling the container, not taking the shape of the container, but filling it. And they're going to be moving all over the place. So they're going to have greater freedom of movement, less molecular attraction. So go ahead and revise that. And if you can, take a picture of it and put it in it'll be phase change student generated model will be the name of the assignment. So you can just put the picture, screenshot, you're going to have to put that on a GoodNotes paper and then turn that in as a PDF. Okay? All right, come on back here to your notes. Unfortunately, I'm sorry to tell you that I don't have a video of what we're doing right now in class. I might see if somebody would videotape it for me, and then I'll put it in GoodNotes or put it in YouTube and see if I can attach it. But I want to do a demonstration in class, and I'm going to show you what happens when we have a phase change and then something else is occurring. And I'm not going to tell the students what's happening. This is just kind of a demonstration, and it's a think about it. What do you think is happening kind of thing? Okay. If the video is in there, watch the video. Let's talk about it. If the video is not in there, talk to me, and I'll see if I can recreate it during a guided study when we come back next week. All right. Have a great Valentine's Day, and I will see you hopefully tomorrow.